Welcome to myprojectbazaar.com. Now we are going to discuss about the project personal identification using a robust Eigen ECG network based on time frequency representation of ECG signals. Now we are going to discuss about the abstract of the process. Person identification or authentication through biometric features has widely applied for basic access and high-level security. But conventional biometrics such as the fingerprint iris tends to be the easily faked or else duplicated by any other intruders. So therefore a new biometric modality is new to overcome these problems. In this process we simulate a new model based on the biometric system using the physical signals of the body. So the proposed biometric system is based on the ECG signals as an characteristic of each subject. This process is based on the three major modules like the preprocessing, feature extraction and classification. Hence by using these three models we can preprocess the signal to remove the noises. Then the feature extraction is applied to extract the basic details like pitches and peaks of the signals. Then the classification is applied to classify whether the input person is authenticated or not. So hence this is the widely used biometric system with more security. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The module consists in this project as input signal, pre-processing, feature extraction, classification and finally performance estimation. At first the input signal is taken from the dataset. The dataset consists of the signals both having the authenticated persons as well as the unauthorized persons. After getting any one signal from the dataset, we just move to the pre-processing step. In this pre-processing step, we have two stages of preprocessor, that is the noise removal and signal limitation. In this noise removal, if the noise is present in the signal, it will be removed, and then the signal limitation. If the length of the signal is more, means the signal will be limited to the length of the signal. After doing this pre-processing, we just move to the third stage of the process, that is the feature extraction. So in this feature extraction, we have four kinds of the features, that is the RR interval, QRS detection, peak detection, then local features. So by extracting these four features, we are extracting the overall characteristic of the ECG signals. After getting the features from the signal, we just move to the fourth stage of the project, that is the classification step. Obviously we know the classification in the sense we have to segregate the type. So hence in this process we have two kinds of objective is there. One is whether the person is authenticated or else the person is not authenticated. So we have to classify these things by using the algorithm, machine learning algorithm named as multi-SVM, that is the support vector machine. By using this classification we can classify the input as authenticated person or unauthorized person. So after doing the classification, we just move to the final stage of the project, that is the performance estimations. In this performance estimations, we have three kinds of performance parameters like accuracy, sensitivity and specificity. By using these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the running procedure of the process. At first open the Python 3.7, then change the current directory like this. So after that, if you want to execute the file, just open the main file.py, then you have to click the run button. Once you click the run button, the new dataset will be open. In that dataset you can see the several data files. So this data file consists of the signals, so you can select any one data signal from the dataset. So once the signal was selected, the process will be done automatically. So this is the input signal which I have taken from the dataset with the title of input signal. After getting the input signal from the dataset, we just move to the second stage of the project, that is the pre-processing. One of the preprocessor is filter, that is the noise filter. So here the noise is filtered by using the filtering method. After the removal of the noise present in the signal, we just move to the feature extraction. Once the signal length is optimum, means we can neglect it, or else if the signal length is too much of long, means we can limit the signal into 5000. After the signal limitation and then the filtering, we just move to the feature extraction. Before that, we are segregating the signal into one wavelets like wavelet signal 1, 2, 3 and 4. This represents the wavelet of low frequency, high frequency, low frequency, then high frequency. After extracting the wavelet characteristic, then we have to detect the peak ranges. So this is the figure which represents the peak ranges. After extracting the peak ranges, we just have to extract the mean, standard deviation and variance, that is like a local features. So the local features from which signal, in the sense wavelet signal. So after extracting everything, so the values will be generated like this, that is the test feature. So this is the standard deviation values, then this is the values of feature extraction of variance. Then after extracting mean, standard deviation, variance, everything, we just move to the classification step. In this classification step, SVM is applied to recognize whether the person is authenticated or not. Once the person is authenticated, the message will be displayed like this, authenticated. Or else if the person is unauthenticated person, means the message box will be displayed like unauthorized persons. Then finally, the performance of the process is evaluated based on the accuracy. So the accuracy will be displayed like this. This is the confusion matrix. Based on this confusion matrix, the accuracy will be generated like this. Thanks for watching this video.